My dear students, till the last class we discussed about interference, and we had interference of two types: wavefront splitting, another is amplitude splitting. We have completed our wavefront splitting mechanism. Then we are proceeding to the amplitude splitting mechanism. How we are getting interference by the splitting of the amplitude. How we will be getting light is coming. How, suppose I will give a slab. That is nothing but due to your mechanism of the slab. Your light will fall here. Then light will be transmitted. So this is one light. Where we will get another light, so that both will undergo superposition, which will give us the interference. That we will see now. So guys, whatever with the light is coming, suppose this medium is transparent. That may be transparent. Maybe transmission is taking place till there is reflection. Partial reflection is taking place. There is a principle called as Stoke's principle or Stoke's treatment. We'll see how this one giving us the amount of reflection. Suppose you have your light is coming from the one second, let me draw properly. Suppose students, you have a glass slab, okay, and I will draw a normal. This is your rarer medium, this is your denser medium. This is your air, this is your having your certain reflective index. Suppose your light is coming. Your light is coming, this is point A, this is point B, and this is having a amplitude A. So what is happening? A part of the light will be transmitted and the part of the light will be reflected. Suppose a light jeti part amar transmit hochi tar amount for T. T amount of the light is getting transmitted. That means T amount of A is getting transmitted. Then I told some part of the light is also getting reflected. That let's consider that is our I. Air amount of light is reflected. R means that is a fraction of light from A. A amar hoji original light. A ro kiछि amount amar reflect hoji, kiछि amount transmit hoji. जोटा कि फ्रैक्शन मुनेली T आउ R. वर्तमान पिला हम किछ सम परे देखिबा. हां, सपोज जेतल तुम लाइट आउछि, when light is coming from the rarer medium to denser medium, light is coming from rarer to denser, that time I will take that this is undergoing a fraction of reflection of R. And when it's going from denser to rarer, still reflection will be there, but I will take it as for my convenience, that is R dash. Same thing, rarer to denser, your fraction of transmission is T, and denser to rarer is your T dash. In the last we will see one amazing and interesting thing, that R and R dash both are equal in magnitude and opposite in direction. What it indicates? Suppose one thing is there is two vector. You think you guys might have very aware of the vector. There is two vector. This is having same magnitude. Suppose these two same, almost same height, right? Same height. Now this is pointing towards, means they have positive direction. Suppose these two have one have negative sign. That means like that. Both are in opposite direction. That means there is a phase. How much is the phase? 180 degree. That is your pi. That means after calculation we will get that this R and R dash is having a phase of 180 degree. That is pi. And they both are equal in magnitude and opposite in direction. Let's separate on this one. Okay. One light, where I am projecting a light here. Okay, students, I am projecting. This is Stoke's treatment. How Stoke treated to get this phase and transmission, reflection, all this concept on this one. Means before going to the interference, you should know these things. So when light is coming, this is having a certain amplitude, that is a part of the amplitude is getting reflected and the part of the amplitude is getting transmitted. I took the reflected part is R and transmitted part as T. So once again I will consider this light. Now I will take in reverse way. Reverse way, actually there is nothing physically reverse way, but for there is a concept in physics. Suppose this is coming this way, means while I will take it in reverse, the same thing I should get. Means ei dita ko reverse kale mate eta miliya katha. That is the principle of reversibility. I will consider that one now. This is your AT. AT, what I told here, when light is going from denser medium to rarer medium, you have transmission fraction T dash. So this is going from denser medium to air medium, and this is your transmission. That means A T with fraction T dash. Try to understand. First it was A with fraction of reflection AR, fraction of transmission AT. Now I will go in reverse direction by applying the principle of reversibility. So AT will be transmitted with a fraction of T dash. Like that, AR is coming from the rarer medium and going back to rarer medium once again. So there is, you can apply only one type of fraction, that is normal R, not R dash. So this will be, when this will go back, this will be A R into R means R square. AR with fraction R, that's why it's AR square. AT transmitting with transmission fraction T dash, so T dash. So like that, this one will be reflected. Okay, this is going from denser to denser medium, means I will take this one as AT R dash. Okay, so this part will also transmit here. What is this one? ART. Is it fine? आउथरे वर्तमान रे पिला देखे दूची लाइट आसिला देखंतु पिला माने ए एम्प्लीट्यूड राइट आसिला ए आर एम्प्लीट्यूड रो लाइट याडे गला रिफ्लेक्ट हैला एटी एम्प्लीट्यूड लाइट ट्रांसमिट हैला वर्तमान रिवर्स जिबी कोटे मते दीटा मिलला वन वे टू वे वर्तमान टू वे को वर्तमान रिवर्स नेबी मु जेतबेले मु वे टू को रिवर्स रे नेबी this way 2 will transmit, means this way 2 will transmit like this with transmission factor T dash. AT प्रथम रो अछि, so जेतले transmit हबो transmission factor उठ लागिवो, that is AT T dash. reflect हबो AT R dash, this one for this one. बर्तमान रे 1 को देखिबा, रे 1 AR reflect हबो. I told na, reflection is there, transmission is there, both things are there in case of transparent medium. Maybe reflection is partial, very less, but reflection is there. AR is getting reflected, same medium, like that. So AR with the reflection fraction R, so AR square, and transmitting with the T, so ART. Now see, so when you have projected a light, this was amplitude A. रिवर्सिबिलिटी कौन कहूचे प्रिंसिपल जित्ती की आस्तिला रिवर्स कले सेत्ती की जिबा कथा. दैट मींस एडिशन ऑफ दिस वन a t dash plus a r square should be a. That is one equation. Another equation is there. जदि इटा हम रिवर्स करिबा ए दुइटा को हमको एटा मिलिबो ओरिजिन रो एटा नथिला. We have assumed this line. This line we have assumed. Originally this was absent. So if we will add these two, ATR dash plus ART equal to 0. I got two equation. From this equation what I am getting? ATR dash equal to negative of ART. Cancel. A cancel. T will be cancelled also. See guys, what you got? R dash is equal to minus R. What I had told in the past, I am going to show something that your reflection coefficient, reflection fraction R and R dash is having same magnitude but in opposite direction, which is indicating that there is a phase change pi. Okay, so now I will see what I am getting here. From the second equation, we got that there is a phase change between the fraction of reflection, that is same in magnitude, opposite direction. And from first equation, we'll solve our a t dash equal to a minus a r square. Simply I took this a r square this side, so I will take common a 1 minus r square. A t dash, a got cancel, t dash equal to 1 minus r square. This is also equation. You have to remember this one. This is nothing but this is called as our Stokes treatment, which is indicating about some concept of our reflection and some concept of our transmission. In the next class, we will study about our thin film. Guys, you might have noticed when suppose drop of oil is floating on a water, or thin film or wedge-shaped film. I will say you what is wedge-shaped film, thin film. Thin film means you have glass slab. तो जोड़े हम blood test करा हुए. Suppose ये हो जोड़े blood test पाएं गोटे glass slab गोटे ये गोटे hour glass एक काढ़े यहाँ को किसी water drop देगी ताकि वो चापी ले ली. तो से भी जो thin film generate हवा that will be your wedge-shaped thin film. Wedge-shaped something will be this structure. This is your thin film. So कौन होची इडी जितने किसी light पड़ला. Suppose the thin film or oil floating on the water, some light is projecting on the oil. Due to reflection, we are getting some brilliant color of light. First time कहूथिले कोन एटा हमर किछि reflection ପାଇଁ होछि, but this is due to your interference. In the next class, we will see how our thin film experiment is giving us an idea about this brilliant color of light, how we are getting. Thank you, students.